Hello, welcome to my presentation for the Artificial Intelligence CA2. For this project, I used YOLOv7 and Tensorflow v2 to recognize pictures of my dog. I did that because my major project is going to involve creating a mobile app which is capable of recognizing people's individual pets using face recognition. So I thought that I'd try out YOLO and TensorFlow 2 for recognizing my dog based on facial images to see how they performed. I used Google Colab, which is like Jupyter Notebook, except it runs in a cloud environment, so it gives us access to more powerful hardware. I got the premium tier, paid a little bit of money for that just so we could get a more powerful GPU to make the training a bit faster. For TensorFlow, I used the default Coco dataset, which is trained, just on dogs. This is a dog, this is a cat, this is a bottle. As opposed to YOLO, on the other hand, I trained a custom model using my own labeled images. I trained for 1500 epochs with 40 training images and 18 validation images. I actually trained it about 6 times. I tried 3000 epochs, but it failed twice. It crashed twice, so I said I'll just try 1500, but actually it performs reasonably well. After trying it a couple of times, it performs to between 40 and 60% accuracy at recognizing my specific dog. So I was happy with that, so it sort of proves to me that it is going to be possible to do this for the major project. So the agenda for what I'm going to talk about here, first off, I'm going to say what is object detection and what is a CNN, how do they work. I'll start to give an overview of YOLO and other single shot detectors because they're complicated. I'll talk about CNN more than them, those algorithms in particular. I'll talk about object detection using YOLOv7. That was one of the tutorials that I followed. I'll tell you about the steps that I took to follow that. And then the second one, another tutorial, was object detection with TensorFlow 2 and the steps I took to do that. Then I'll do a demonstration of the results, the performance of these algorithms. I'll explain inference using images on Google Colab and inference via the webcam on TensorFlow 2. So first off, object detection. What does it do? We see it all the time, but probably don't recognize it. We sort of forget that it's there. Unlocking your smartphone uses face recognition. That's object detection. Here's a person. Navigation for self-driving cars, looking at all the objects around them so they can navigate safely. And they're underpinned by computer vision, deep learning, and convolutional neural networks, and obviously image processing as well. So the past methods for object detection, maybe 6-7 years ago, supposedly. I wasn't doing this back then, but apparently this is what they did. There would have been 3 stages to object detection. They'd have informative region selection, which used sliding window, whereby they'd take a portion of the image at a time, and they'd move the window along, looking at every part. And that was computationally very expensive. The second step was feature extraction. Today we use CNNs, but previously they would have used they would have manually extracted the features of the image. So to recognize different objects, we'd have to identify their unique features, and that made it difficult to make a robust model that would perform, it was generalized, that it performed well across data that I'd never seen before because of variations in lighting and occlusion of objects and stuff like that. And the last stage was classification. So we use machine learning for this beforehand. Previously, we'd use logistic regression, support vector machines, or the AdaBoost algorithm, whereas these days we use CNNs. So the 2 algorithms I used in this project were YOLOv7 and SSD, as I say. The new methods, as I say, include YOLO and single shot detector SSD. They only have 1 step. They combine all the previous 3 steps that we talked about there together, and it's much faster. You can see in that diagram there, I'm using YOLOv7, the latest one. It's not out that long. Actually, it isn't the latest, sorry. There is YOLOv8, but that's very new. YOLOv7, they claim to be 120% faster than their predecessors. I can't really confirm that personally because I haven't used YOLOv5, but we take them at their word. It still has very good precision. That's MAP, mean average precision, is still very high. So YOLO uses a CNN to predict an object's bounding box, and it makes a class prediction at the same time. It works by dividing the image into a grid of equal regions, where each region is going to be responsible for detecting and localizing the object within it. And the grids individually predict their own bounding box coordinates with respect to where they are in the image. So YOLO and SSD use CNNs to make their predictions, but the question is, how does a CNN work? For a quick overview, CNNs are a type of deep neural network, mainly applied to identifying objects in an image, but they're also used for NLP projects, natural language processing. So how does a normal neural network work? Because they're similar. A standard artificial neural network consists of a series of interconnected layers of neurons, artificial neurons, where each layer receives some data, performs some calculations, and then passes it on to the next layer. And CNN is just a variation on this, whereby there are convolutional layers which contain filters, and they perform the pattern recognition. This explanation came from IBM. A filter, they said, could be defined as a 3x3 block in which we search for a pattern. We'll take the pattern the filter found, examine the corresponding pixels in the image, and then determine a score for how similar the pattern we found is to that area in the image. We combine those filters, then they call that pooling, and then once we've done that enough times, we have a good idea of what's represented by the pixels to make up that whole image. You start off, the first layer might just pick up edges or simple shapes. Then as we progress through the layers, we're going to start getting more complicated. We might pick up aspects of an object like, say, facial features, hair, eyes. Then by the time you get to the later stages, the later layers, we're picking up entire objects like people or dogs, whatever it might be. And that's it for my slides. Next thing, first tutorial I'm going to look at is object detection using YOLOv7. So I did this one in Colab. The first tutorial, so disconnected there, the first tutorial that I followed used YOLOv7. As I say, it's supposed to be 120 times faster, 120% faster than the predecessors. Now the reason that I use Colab is because locally, my laptop does have a graphics card, but it's not CUDA capable, so it's no use for machine learning stuff. So instead, I used Google Colab and got the premium version to get access to one of their good GPUs. In this first line, on this NVIDIA SMI to check which graphics card I have. Now that's showing an old one because my compute units actually ran out, but I did have a nice one. And then next thing I do, I clone down the entire YOLOv7 repository. And that repository has a requirements.txt file. So I use pip install requirements text, and we install all these libraries that YOLO needs. Scrolling down, the next thing I suppose I'll talk about is data annotation and preparation. To label my images, I use this thing called label image, the label image program. For YOLO to understand what we wanted to detect, we need to annotate the pictures. You can't just give it pictures. We have to say, here's what I'm looking for, here's a bounding box, and what it is, a label for it. It only accepts labels in the YOLO fashion, whereby it's going to have coordinates, a lot of text files associated with every picture telling you, here's where what I'm looking for is. So I'll show you this. This is a labeled image. And that's Lola, my dog. And you set it to what type of labeling you're going to use. I said YOLO. We create a bounding box. Try and get as tight as you can to what you're going for. So for example, I did this 50 times or so, but I type in there Lola. And there we go, now we have it labeled. I did this over and over again to create our training data and our validation data. So once we give these images to YOLO, we're going to have a corresponding label file with the coordinates for every bounding box to say, here's the dog's face. The next thing we did then, we're preparing our training data. So there's sort of some configuration stuff we have to do with YOLO. See, we have our training files and they aren't there because Colab shut down on me. But if we were to run this again, which you can do because you can get them off my GitHub, we iterate through all of our images. Again, they're gone because Colab restarted this lab. We iterate through all the images in our training data and we get all the paths. We save the paths to a train file so that YOLO knows the location of our images. So that's what we're doing here. We're saying open up our training.txt file, and then we're saying get all of our images that we would have in one of these folders. I have them stored here on GitHub. And we say for every image in the list, just write the location of the image to the training file. We do the same thing then with the validation images. Scroll down in my notes here. Now, next up, inside the YOLO folder, we're going to have a folder called data. And in there's going to be a file called coco.yaml, which contains the label data for the Coco dataset. That's what YOLO was trained on by default. But I make a copy of that file. And then I change the default number of classes from 80 down to 1 because I only have one. And then I replaced all the existing classes that it uses, like person, dog, bike, whatever it might be, with just one label, Lola. That's the dog's name. So I updated the locations of the training and validation text files so YOLO knows where they are when we're going to train them. Next thing I did then, I downloaded the pre-trained model from the YOLO model zoo. The one I used is just called YOLOv7 because supposedly it's one of the fastest ones. That was especially relevant to me because I'm planning on one of my major projects on a Raspberry Pi, so I thought I may as well see what the more lightweight models are like. Next up was the model training. So there's a config file. Sorry, I mentioned that already, how I changed them from 80 down to 1. Now, first off, I trained this to 100 epochs just to give it a go and see what it'd be like. I patch in a batch size. I pass in a batch size of 16. 16, I think, is about middle of the road. I did that because we have 12 gig of RAM in this Colab instance, which it's not bad, but it's not great. So I said we'll go middle of the road. I tried it with 100 epochs. Now, the person doing the tutorial advised that's not much at all. As I say, I went for 3000 later on, but Colab crashed twice trying to do that, and that was about 6 hours wasted. So I said I'll just try 1500 next time, and 1500 performed well. So in here, I pass that custom configuration file that we made, which is pointing to where our train data is, and our validation data. And I pass in that that model that we downloaded over here. Next up, what are we going to talk about? Evaluation. Skip that because that's when I would have tried to evaluate this on the 100 epochs. It didn't perform well at all. You can see down here, I tried it again with 1500. And now I can't actually show you this live because Google Colab disconnected on me, and if I were to try and train this model again, it'd take me easily 2 hours. But you can see it going through the training there, and the MAP improving over time as it trains. And when I tested this, actually I'll point out this last part here. I got this code snippet from Google, which enables you to open the webcam. I could show you this, I suppose. Take photo. To run the previous one first. Allow the camera. Fail to allocate video source. Don't know what's going on there. Anyway, going down to the bottom, this is where I tested on an image that I took of the dog. Again, as I say, I can't show you this live because I'd have to train the model again. But here's one I made earlier. Open image. Bit slow. I should just go down here. So there's me with the dog holding it in front of the camera, and it gets nearly 60% confidence that that's Lola. That's what I trained it on. So overall, I think it worked out very well. I'm going to be confident now to use YOLO, I think, for the major project now in the future. The next thing that I want to show you is object detection with Tensorflow 2. So for the second tutorial that I followed, I used Tensorflow. Because, as I say, for the major projects, I'm going to do something along the lines of what I have here, so I thought it'd be good to compare YOLO with Tensorflow and see how they perform. Now for Tensorflow, I couldn't get it to run on a custom dataset. I did try, but turned out that running this locally, it didn't work out well because I don't have a CUDA-capable GPU. So instead, I just used the Cocos dataset rather than training it on a custom dataset. And it worked out fairly well. You know, it can say, here's a dog. It knows that it's looking at the dog, just it doesn't do like what I'm showing you here. It won't identify my dog. So TensorFlow 2, it's a library for, it provides lots of tools for building machine learning apps. It's made by Google. Now with this one, there was very little coding involved. It was more just about setting up TensorFlow, but sure, I'll explain the steps that I went through anyway. First thing I did was clone down the official TensorFlow repository. So we have this here, the TensorFlow model garden. That's where I got it from. I also had to install a library called protobuf, which is needed for installing protoc files. And there's some of them included with the TensorFlow repository that I got. So I got that from the protobuf GitHub repository. I needed to be able to call the protoc application anywhere, so I added that to the Windows path to be able to call it wherever you want. And after making a TensorFlow 2 virtual environment, I installed TensorFlow as a package inside that environment. Then I used a simple script from the creator of the tutorial, which just activates all those protoc files. That was pretty much all there was to the TensorFlow setup. The next thing was to set up an IDE. I used DataSpell. It's this fella here. It's just a data science IDE made by JetBrains. So with the IDE set up, I added a couple of scripts written by the author of the tutorial. They're for detecting images and, well, one's for detecting images from a webcam and the other's for detecting images from pictures you've already taken. He has one for videos as well, but I didn't use that one. I'll just show you this. This is his script for detecting from the webcam, detect from webcam.py. The main part of this, I think I want to show you, is the inference function. Run inference. You can see we have this while true. That's just an infinite while loop. So we're saying while you're getting input from the camera, run this visualize boxes and labels on image array function. And that comes from these viz utils, which is up here. It comes from the object detection utils, which we get from TensorFlow's object detection library. So we're just saying here, once you're getting images from the camera, keep running the inference. And you can see down here at the bottom, we say run inference, and we pass in the detection model. The detection model that I used, what was the name of it? I have it here. It was a SSD mobile net, so a single shot detector. And I used that one because it's meant to be a very fast one for doing object detection in real time. I went with that because this is running on a webcam, so it has to be real time. So yeah, that's the inference function. That was the main thing I wanted to show you there. That's where we run it. And I'd like to demonstrate doing this inference in real time, so I'm probably going to have to come back to you in 2 seconds because I have to go and get the dog to show you this. But sure, I'll run this. You can see we're running detect from webcam, that script. We're saying this is the model that we're going to use. We're passing in the COCOS labels for the COCOS dataset. We get this warning here, ignore if you don't have CUDA, but I don't, so we will ignore that. TensorFlow won't run at the same time as my recording software because they both want access to the camera. But anyway, here's Lola, and you can see that TensorFlow is picking her up because it's trained on the COCOS dataset, which knows what a dog looks like. So there we go. 60% confidence that this is a dog. 60, 75. Lovely. I'll put her down now because I think that's all from me. This has been my presentation for the Artificial Intelligence CA2. Thank you very much.